record on this computer. Okay, so this first question is just changes of state. We start with something simple, something very, very simple that everybody can do. Okay? Can? Okay, just do question one. Just do question one. We just do warm up question first. Try, try. Question, just do question one. Question two, I'll teach you. Because it's still just sharpening the brain. Okay, so three states of matter are solid, liquid, gas. Okay, so very easy lah. All right. So if you got this wrong, we can sit down and cry. Okay, from liquid to solid, freezing. Okay, from gas to liquid, evaporation. No, sorry. Got the thing. I was reading it the other way around. From solid to gas is called sublimation. Okay. All right. Okay, so this one, right, is very easy lah. You just draw circle, flower. Very easy. Okay, as long as they're not touching. Right. So for IG, they will always ask you what? Actually, not only IG lah. Normal questions, they will always ask you the movement. So if they ask you movement, this one is vibrate in fixed position. Okay. If they ask you lah, movement, vibrate in fixed position, this one is slide over each other randomly. But this one is just random. So gas very fun one. Gas, the movement is random. For gas, the arrangement, they will also ask you the word arrangement. So for gas, the arrangement is also random. And for liquid, the arrangement is also random. But for solid, what is this called? What is the word? Lattice. It's a lattice arrangement or a regular arrangement. Okay, complete the diagram by drawing six circles. Okay, six are all your magnets. 1, 2, 3, 4, 5, 6. Okay. The statement is correct about the substances. The atoms move randomly in the gas state, correct? Okay. Random move solid state, no. Atoms are fixed position in gas state, no. Atoms are fixed position in liquid state, no. Okay, simple. Okay, this one, actually, conversion of water into ice. This one is liquid and this one is solid. Simple, right? Okay. Now, do you guys remember the heating curve and the cooling curve? Do you remember? Okay. So heating curve is like this. This is the temperature and this is time. Okay, so it goes like that, like that, like that, like that, like that, like that. Right. Okay, so it starts with solid, and then here's solid plus liquid, and then here is liquid, and then here's liquid plus gas, and then here's gas. Okay, now if the question asks you for a chemical equation, and let's say this is water, they ask you for chemical equation here. It's actually water in the form of solid, reversible with water in the form of liquid. That's what it means by the change of state. That means it's a mixture of both. Why is this one different? This one is conversion of water to ice. They're just asking one. But if it's here, and if it's here, then it's also reversible. Get it? That's what it means by two states. Oh, I'm scared. I'm cold. She's not cold, she's stuffy nose. Oh, sorry. Can I understand? Simple? Yeah? Alright. Okay, this one, right? It's a mixture of all the topics together. So RG also a question like this. Same question. They will give you a list of elements, or they will give you a list of gases, or they will give you a list of substances or chemicals, and then they will ask you, how does this made? So it's all the chapters combined together. So sometimes you haven't learned all the chapters, but it's okay. Now this chapter you definitely, even if you haven't learned, you learn in year 7, where oxygen and nitrogen is part of gas in the air. So oxygen is 21% and nitrogen is 78%. That one, you cannot say, oh, teacher, I never learned before. No. Okay, generally what they will ask you is the use of chlorine. Chlorine is used to bleach uh, clothes, but most important is to kill bacteria in water, right? Okay, it's to disinfect water, swimming pool water, drinking water. Hydrogen chloride is actually HCl. It's a gas until it dissolves in water. When it dissolves in water, then it becomes hydrochloric acid. So the difference is it's when it's a molecule, it's not yet dissolved in water. It is an acidic gas, but it's not an acid. In order to become an acid, it has to dissolve in water. Okay? All right. And then hydrogen is the lightest gas, lah. All right. So easy. Uh, name the gas used for combustion, oxygen. The gas that's most abundant in air, nitrogen. Okay. The gas that can bleach litmus paper is chlorine. Why is hydrogen chloride classified as compound? It's a two different elements and then chemically bonded together. Okay. Got it? Okay. Why does chlorine have the highest boiling point in the gases in the table? Okay, so why do you think? If you look at the periodic table, okay, never mind, I tell you lah. The molecular mass, chlorine is 71. This one is 36.5. This one is 32. This one is 28. And this one is 2. So the molecule of chlorine is the heaviest. So what is the strongest? Is the intermolecular forces of attraction, or the forces of attraction between molecules. Okay, Ken? Got it? All right. Do you have the books yet? No. Okay. You wait for Mr. Jeff to come back. He probably passed to you lah. Are you coming for chemistry and biology or just chemistry? Only chemistry. Only chemistry. Okay. Now today I will use the books yet. Okay. Next week only I use. All right. So it's not chlorine. Not chlorine has the strongest covalent bond. Remember, covalent bond is between chlorine and chlorine. This one is strong for everybody. Okay? We are talking about the bond that is in between the molecules here and here. This is called intermolecular force of attraction. You can call it Van der Waals, or you call it force of attraction between molecules. Okay, so it has the strongest force of attraction between its molecules. So this is D. This is a very big difference, huh? Right? All right. Then, yeah. Hydrogen peroxide decomposes. This one, okay. Although you have not learned, like officially learned, but I think you should know. How do you test for oxygen? You take a, you learn this, you two must learn before, because you learned this in year 7, year 8. Yeah, yeah. Come on, come on. Yeah, glowing splint. Okay, so remember, to test for oxygen and to test for hydrogen is almost the same. Okay, oxygen is like that, glowing, no fire. It's glowing. And then when you put it inside, Not like that. When you put inside, it will relight. It will become a fire. Hydrogen is you put in something with a fire already. Put it in a burning split. And when you put inside, it will pop. Okay, so hydrogen, oxygen different. So it relights a glowing split. Okay, it relights a glowing split. Okay, so can hydrogen is different. Okay, so from here to here is a question that I'm going to teach you in a while. I'm going to teach you later. Okay, I'm going to teach you later because this is a new chapter that I will teach you today. Rate of reaction. Okay, are you done with this? Done. Okay, good. Okay, so this one is a new chapter I want to teach you today. Rate of reaction. Okay, because everybody does that. Okay, can so what I want you to do is look at this. Okay, this one can lah. Everybody has learned this. I've taught you this many, many times. Okay, you all should know this. Okay, so this one you also have learned because you learned chemical bonds already, right? So I want you to do question six. Six. Just question six. Calculations, have you learned moles calculation? Uh, Alright, I'll teach you how to do later. Alright. Okay. Do question six, then I'll explain question seven. If we have time, we will do the new chapter. If we have no time, it's okay. We will do it next week. Alright? Alright. So this one very easy, positive, negative, okay? Alright, so if aluminium is 3 positive, chloride is 1 negative, just move the 3, so it's AlCl3, right? Okay, then this one is 2 positive, 2 negative can cancel each other out, ZnSO4. This one, okay, so this one is, huh? Oh, sorry. Okay, I'm going to update. Please don't update. Update, okay, what was I doing? NH4 bracket 3. And this is a bit weird, right? But yeah, this is the formula. Lah. You get it? Okay. Okay. Formula of the compound AlSO4 is aluminium sulfate. Okay. Aluminium sulfate. Okay. Now, when do you do the numbers 2 and 3, iron 2, iron 3, only for transition metals? Group 1, group 2, group 3 don't have all those numbers because group 1 is always positive 1, group 2 is always positive 2. Okay? Okay? All right. Okay. So diagram shows a ratio electron, magnesium, chlorine. Okay, describe in terms of electrons what happens when magnesium atom and chlorine atoms form magnesium chloride. So each magnesium atom releases two electrons from where? From its outer shell. Each chlorine atom receives how many? One electron into its out. Hey, what's this? Its outer shell. Okay, do you know why? Do you know why? Because, hey, where's your glasses? There. Okay, you must always wear glasses. Magnesium 282, so it will release 2 to become full outer shell. So it become Mg2 plus 28, so it's happy. Then Cl is 287. It will receive 1 to become Cl negative 288. Okay. All right, so what happens? Not yet finished yet. We form magnesium chloride. So magnesium ion and chloride ion. What forces connect them together? Electrostatic. Okay, combine together with electrostatic forces of attraction. Okay, electrostatic forces of attraction. All right, can here complete the dot and cross. So nitrogen is 2, 5. Hydrogen is 1. Okay, they don't ask you to draw the inside one. They only ask you to draw the outer shell. So 5, do they ask you which one use what? So you can up to you lah. So 1, 2, 3, 4, 5. This one. Okay, got this? Yeah? Easy, yeah? Describe, okay, this one, right? This one, the answer is different for IG and SR. Only this one is different. Okay, so for IG, okay, it is all right. The covalent for IG is just sharing of a pair of outer shell electrons between two atoms. Okay, that's it for IG. Just like that, very easy. Okay. Okay, next cell is different. Remember I taught you? What did I teach you? Why? What did I say? It's between what? The valence, valence, valence electron. Do you remember not? Okay, there. It is the electrostatic force of attraction between shared pair of electrons. And the nucleus is different. It is different for, wait, I show you. It is different for an XL. Okay? I put for you. Do you know why or not? You know what this is talking about? Okay, so it means that this one has a nucleus. Here has a nucleus. Nucleus is positive or negatively charged? No, nucleon is zero. But in the nucleus, there's proton and neutron, right? So the neutron is zero, but the proton is positively charged. So the electrons are actually attracted. So not only my own electrons are attracted, but other people's electrons are attracted. That's what it means. So here also got nucleus. So this nucleus is also positive. So this nucleus also holds onto the other pair of electrons. So that's actually, it's not wrong. It's just asking different things. Okay, so for IG, they're asking this one, what is a covalent bond? For NXL, they're asking you why there are attractive forces between the shared electrons and the nucleus of the two atoms. Get it? Okay, all right. Okay, this one, it's not calculation. So it's very simple. Okay. It's like this, all right. Uh I have I have cloth. Okay. I dip my cloth in water. Now my cloth is wet. I want you to tell me what is the best of the cloth only? What must you do? Take out the water lah. Right now. Okay, you cannot leave it to hang like that because it take too long. So what you do is you iron the cloth so that it becomes dry. But sometimes you iron, it's not fully dry. So what you do is you iron, then you go and weigh. It's 10 grams. Then you go and iron some more and then you weigh. Then it's 9.9 grams. Alamak, what does that mean? It means that actually 1 more gram of water lost. So you go and iron again. Now it's 9.9 grams. Now is it correct? Yes, because it's constant mass. Okay, this is exactly the same. Okay, this kind of crystals, when they put here XH2O, okay, right now the word here is called hydrated. It's a hydrated salt. Hydrated means the water molecules are chemically bonded to the salt. Okay, now it's not X, it's not unknown, it's known. They want you to find out how much water. Okay, get it? So in order to find out how much water, what I need to do is I find out the mass of the water. That means how much water. So in this example, it's different lah. After I iron, I see how much water is lost, and I compare it to how much dry cloth I have, and I compare what is the ratio. So that's how I find the value of X. Get it? Okay, so this one is just heat up, heat up, heat up, heat up, heat up. Give the reason why the student surrounds tube B with ice. So I want to know how much water. Okay, so so this one when I heat it up, the water comes out as liquid or gas. Gas. First, the water comes out as gas. So it goes inside here. Why do I put water? I want to condense the water vapor. Okay, so to condense water vapor to water. So you can see here that this one, the last two readings are the same. So when it reaches a constant mass, it means that the finish already lah, all the water is released. Okay, so then when the uh, mass of tube B is constant, when the mass of tube B is constant. So you see here is constant, right? There, 22.1, 22.1. Okay. All right. Describe a chemical test. Okay. So this one, you all need to write down a bit. There is a difference between contains water and pure water. Pure water meaning I'm testing the purity of water. Contains water means I'm testing the presence of water. Okay, okay, now which one is 100% pure water? The first one or the second one? The first one. Okay, second question. How do I know they're asking me one or two? Read the question lah. If the question says, how do you prove the water is pure? Then you're talking about the first one I'm teaching you lah. How do you prove that water is present? Then you're talking about the second one. Okay? Water is present means got water or not? It can be dirty water, it can be tap water, it can be pipe water, it can be water from my water bottle, it can be tea which has water that contains water. Purity water is 100% water. So this one is test the this is chapter 1. Come on. You've learned before. Test the boiling point. Okay. It boils at 100 degrees Celsius. You can test either boiling point or melting point. Okay. But it must be exactly 100. Because impure substance, when the temperature goes up, when you add impurities, right? Okay. Presence of water, there's two that you learn. Okay. That means got water or no water. One is called anhydrous copper 2 sulfate. Another one is called anhydrous cobalt to chloride. This is to test whether there is water or not. Okay, remember just now I taught you the word hydrated. Hydrated means there's water crystals. It's not wet, it's water crystals chemically bonded together. Anhydrous means don't have lah. Okay, this one, if it's anhydrous copper sulfate, it changes from white to blue. That means the original color of the powder is white. When you add the liquid, it changes to blue, means it's water. Okay? Cobalt chloride is blue to pink. Teacher need to remember, yeah. Okay? Huh? Yeah. Yeah, I need to remember both. It's in the chapter that is the testing of salts one. The one that you did lah. Remember in school that one? That's the one that you must remember both. You must remember both, okay? All right. Yeah. Okay, the decomposition of hydrated magnesium sulfate is shown in the equation. Okay, so like this, Okay, so this one is 6 grams. Okay, but you started with how much? Then the water is how many grams? There, the mass of tube B. All right, heat and collect the water. So the here is it's not 22.1. The original mass is 15.8 without water. Don't just take 22.1. At the end is 22.1. So the mass of water is 22.1 minus 15.8. Okay, so water is 22.1 minus 15.8. How much is that? Oh, 6.3 grams. Okay. All right. So this is how you count. This is called, what is this called? Molar mass. Okay. So the formula is mass over molar mass. What am I looking for? Amount of moles. Have you learned this formula before? Um, you're going to learn it after you learn what you're learning now. Okay, it's called amount of moles. Wait, it's a measurement of chemistry of particles. Amount of moles is mass over molar mass. Okay, so we calculate the amount of moles of MgSO4 and we calculate the amount of moles of water. Okay, so the mass of MgSO4 is 6 grams. So 6 is mass, molar mass is 120. Okay, so you use calculator, how much is this? Water is 6.3, and then the molar mass given is 18. Okay, you got calculator? Okay, so how much is this? 6 divided by 50 is 0.0. 6.3 divided by 18 is... Okay. Right, to find x, we take the big number, divide the small number, which is 7. Okay. Okay, you understand? You just find the ratio. This one, wait a while. When we're talking about rate of reaction, we'll talk about this. Okay. So we're gonna do a new chapter today, but I want to recap some of the old chapters. Yes. You all okay? Need a break, Lolita? Need a toilet break? Lolita? Okay. Okay, let's look at this. Yeah, go take a break. Do you want water? Go take a break. Okay. Do you know where the toilets are? Yeah. Okay. All right. Okay, this one. Okay, this one, actually, all of you should know. Okay, try and do. Question one. You should be able to do one A, B, B, B. You should be able to. Okay, because you're learning so you're learning periodic table, right? In school, you're learning periodic table already, right? I think so. Yeah, yeah, yeah. Yeah, you just told me just now. Yeah. So you should be able to do answer B. Alright? Yeah. Try question one. Let's try question one. It's okay if you get it wrong, okay? I would like send you to the corner and make you sad. Okay. uh my son's accounts teacher. It's okay, make all the mistakes, make all the mistakes. Just make sure you make the mistake before your exam. Make all the mistakes during practice. It's actually a good concept. Okay, atomic number 16. Who has atomic number 16? Hmm. Okay. So elements with atomic relative atomic mass. Sulfur, the 32 is atomic number is this one. This one is 9. It's the big number. So what is it? Huh? Beryllium. Okay, because beryllium is what? 2 4. Okay. Give the name of the element in group 3, period 2. So group 3, period 2. Period 2 is boron, not aluminium. Don't get tricked. Because period 1 is helium and hydrogen. Okay? So, all right. Give the electron ratio of atom of silicon. Silicon is 14, right? It's 2, 8, 4. Okay, this one, again, dun, 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 there is different answers for IG and NXR. Not in terms of they're teaching the different thing, no, it's just that you have to learn a different depth. Okay, this one you learned already. Sodium is more reactive than lithium. Lithium is 2-1. Sodium is 2-8-1. Okay, for IG, all you need to know is as you go down group 1, the reactivity increases. IG, that's all we need to know. Okay, that's all you need to know. Going down group 1, reactivity increases. So you need to know when you put lithium in water, it will fizz. But if you put sodium water, it will right, right. Okay, so for IG, that's all you need to know. Okay, what I'm going to tell you now, you don't need to write down in your IG, but it's good for common knowledge because actually that's how we learned it last time. I don't know why they take it up in IG, but for Edison, you must know this. Okay, clear? This part I'm going to teach you. So Alexa, it's actually very interesting. Okay, so lithium is 2 1, right? 2 1. And sodium is 2 8 1. Okay, so there's 2 and then there's 8. Okay, so what when it's reacting, right? Actually, how does it react? It gains electron or releases electron. It releases 1 electron. So obviously, who releases electron faster, sodium or lithium? Sodium. Okay, so the reason is because the electron is here because it's held by who? Same as just now. The electron is negative, right? Electron is held here by who? Who is the one holding it? The nucleus. Because the nucleus is positive, right? So this one is all held together by the nucleus. But who is bigger? Lithium or sodium? Who's bigger? Sodium. So the attractive forces is stronger or weaker? If I take this, I throw at you, and I throw at you, which one more painful? What? Go nearer, what? So stronger attractive forces lah. So it's further away, so it's weaker. So this one can escape faster. Get it? So for your 3 marks, you need to write the atomic radius of sodium is sodium. Sodium is bigger than
So I think I'm going to like the first slide.
no. The first one I'm going to write.
Really?
Yeah.
What else do I learned it like that?
You read it like that?
Yeah, IG version.
Yeah. I mean it's correct. It's not wrong, but you need to answer this for your exam.
Mm.
Okay. So the attractive forces between wait, let me see if you have to write valence electron or just electron. So I'm going to larger the less attractive. Okay. So the attractive force between the outer shell, electrons, and nucleus is weaker for sodium. So it is easier for sodium to release electron. Okay? So this will be your 3 marks for your NSL, okay? 1, 2, 3. Actually, like you see, most of the answers are same. Everything we learn mostly are the same. Only this one is slightly different. Okay? NSL is a 3 mark for this. Actually, only got 1 mark. So going down more reactive, which is the same thing, right? They learn going down more reactive. You learn why is it more reactive. Why you learn that? I don't know. It's also important. Actually, it's important to know. So then you know why is it going down more reactive. So group 7 is just the other way around because they're catching the electron. Right? Actually, it's better when you learn the reason behind it. Then it'll make more sense. Right? Okay? Alright, okay? The scientist this one electrolysis. Okay, you haven't learned yet, right? Have you learned? No, okay, never mind. I explain to you. So this one did you guys do? Haven't? You learned already, right? Okay, come. Okay, but this one you learn. This part you learn already. This one you learn already. Okay? Uh, okay. Lead 2 bromide is PbBr2. Is it ionic or covalent? Ionic. Ionic compound can conduct electricity in solid or molten. Molten, why? It has ions, but the ions must be freely moving. Okay? So this is the same thing. So this one, I am happy to say that both your syllabus will ask this question for 3 marks. In solid And you must answer the same way. Lead to bromide. The keyword, ions are solid what? Ions are in lattice or in a fixed position. Both also can. Fixed position. In molten, uh, the ions are really moving. Let's move freely to conduct electricity. Okay. Okay. Wait. Okay, no worry. Dah. Finish copying it. Uh, oh, my nose is so stuck. Ready? All right. Okay. 400 degrees Celsius. What is the electron made from? Gra Graphite. Okay. You know what's graphite, right? Why must we use graphite? Because graphite can conduct electricity and has a very high melting point. Okay. So graphite, high melting point, conducts electricity. No, 400 platinum will melt. Platinum is a metal. Metal will melt. Right? Even if it doesn't melt, it will become it will become softer because it's very high temperature. So molten only can use graphite. Okay. Alright, so this part you might not understand. It's okay. I'll explain to you, okay? So what happens is in molten, the ions are freely moving. Pb2 plus and Br negative is freely moving. So the negative ion will go to the positive electrode. The positive ion will go to the negative electrode and they will try to turn back to normal. So for example, Pb is 2 plus. That means it has already lost electrons. It wants to change back to element, it needs to receive back the electron. Get it? So that's what's going on here in electrolysis. Electrolysis means to break down the compound back to its elements. Half equation at the negative. So the negative is what I just wrote for you. The Pb2 plus receives electron to form back Pb. Okay, Claire, you got this correct? Remember we did like 100 equations. Okay. So what is observed? Here you will see what color gas? Wait, I want to see what color at the cell thinks the gas is. Ig thinks the gas is brown. Okay. Then yours also thinks it's brown. Okay. So bromine is brown gas. Okay, do you know why? Because bromine is brown. So bromine will be formed at the positive electron. Okay, oxidation is because it releases electron. This is another chapter lah. You will learn again next time. Okay, releases electron is oxidation. Ay, this one same as this one lah. Do you remember what? Can you remember how to answer? No, this one you two will answer. Do you remember how to answer? No, 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 no. Covalent. Remember I was telling her just now why the covalent. So for Ig, you say they share a pair of outer shell electron between two atoms. But for what was you say? The nucleus and the electrostatic forces of attraction between the nucleus and the shared electrons. Okay, can you remember? Same answer as just now. Same answer as just now here. Where was it? Yeah, this one. This one. Same answer, okay? It's not very important. Alright. Then you can copy it. Same answer. So the IG one is different. It's actually not different. It's just we're talking about different things. Uh, oh, I need a new nose. Okay, this one is later on. Later on, but I explain to you a little bit lah. Okay, so just now Taeyun said, isn't this ionic? Right? That's what you said, right? Okay, so it's actually not. Okay, you see, when it's HCl, it's a molecule. All right? An organic solvent basically means a liquid to dissolve something which is not water. Okay, if I want to make hot chocolate, I take hot chocolate powder and I dissolve it, water lah, hot water lah. Water is my solvent. If I want to make salt water, I take salt and dissolve it, water. Anybody want to make hot chocolate, take hot chocolate, dissolve in alcohol lah. The drunkard cocoa drinkers are maybe lah. Okay, but then if I take perfume, the I squeeze out the oil, okay, the oil from the flower, and I cannot just sell like that, one drop, right? So I have to dissolve it in something. So I dissolve it in alcohol. Then alcohol is my solvent. Get it? So an organic solvent is basically like ethanol, anything with long names that you don't know. Tetrachloromethane, hexane, hexene, all these long names that you don't know, these are all organic solvent, basically not water. So when you take this molecule and you put it in an organic solvent, when you put this in an organic solvent, what happens is it remains a molecule. It stays a molecule. It does. So if you put HCl in alcohol and you go and touch it, your finger would burn. Can you understand? Okay. But if you put hydrogen chloride gas dissolved in water, ions are formed. Okay, so it means that if you take HCl, that's what everybody learns that, and you put in water, this one you will learn in acid, base, and salts, but they don't learn so detailed. It will split apart to become hydrogen ion and chloride ion. So when there is hydrogen ion, now it's acid. Ding, 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 it's acid. Now you put your finger in there, it'll be painful. Can you understand? Okay, so this question is asking you, explain what happens when dry glue litmus paper. So litmus paper is to test the presence of what? Dry glue litmus paper is to test the presence of acid. So blue will turn to red. So if you put in okay, if you put your blue litmus paper in this, and you put your blue litmus paper in this, which one will have a change? Only water. This one will remain blue. Okay, can? Alright, so how to write there? Okay. Alright, so in the organic solvent, the litmus paper stays blue because there is no hydrogen ions. Okay, it's not an acid. But in water, litmus paper turns red because it has formed hydrochloric acid. Okay, so these are your 4 marks. All right. Okay. Better? Okay. Let me put this here. All right. Do you remember this? We did this last week, ah? Do. So last week, we learned about endothermic and exothermic reaction. Okay? All right. Yeah, you were not here last week. So I'm trying to remember your name, okay? So you were here last week, right? So we were learning about something called endothermic and exothermic. Basically, in any reaction, hey, do. Yeah. Why don't you remember how to do? Try. Okay? In a chemical reaction, you have to break the bonds first. You can look at last week's notes. Okay, first you need to break the bonds. So here, this is this bond, all right, and this is this bond, all right. So in order to break the bond, the reaction will absorb energy, okay. And then after you break, so it's basically H and H must break up with each other, Cl and Cl must break up with each other, then only HCl can go together. All right. So the one at the back is to form bonds, which is this energy. All right. So what you do is you first calculate your step one is to calculate energy absorbed to break bonds. That's always the first thing that happens. Basically, what I call energy inlet. Okay. All right. And then part two, you calculate the energy released to form bonds. Basically, there's energy out. Here we call that out. All right. So now I know it's like money lah, money in and money out. So after I know how much money in and money out, I can calculate enthalpy change. Enthalpy change is always you take in minus out. That's all. You don't care whether it's who is bigger, who is smaller. You just take in minus out. Okay. You want to try? Just try it. Okay. You must be able to do and draw the one below. I taught you before already. I taught you last week. Just taught you last week.
Would you explain a step one in charging
Okay. So, got answer already. How much?
negative 184?
Okay, good. Okay, so like this is hydrogen, right? But actually, hydrogen is H bond H. All right. So what we need to do is we need to break the hydrogen bond first. In order to break the hydrogen bond, the amount of energy that is required is 436. Get it? So how many hydrogen bonds are there? One only. Don't confuse these two. It just means these two. Okay, so chlorine, same concept. Chlorine is actually ClCl, and we need to break this bond. So the amount of energy to break this bond is only 242. So there's only one of it. So basically, we break this bond and break this bond. We just add these two numbers together. Okay, so 436 plus 242, how much? 678. Is it? Okay. So this one is kilojoules. All right. Then after that, now my atoms are free, right? Okay. So I want to form the bond. So to form this bond, to form this bond, every one bond is 431. But how many bonds do I have? Two. Can you see? All right, two. So to form bonds is 2 multiply 431. So it is 862. Okay. So basically, this is the value of in and this is the value of out. So this is how much I paid and this is how much I spent. Basically, like that. So in is 678 minus 862. So if the in number is bigger, your value will be positive. It is the endothermic reaction. You learned endothermic last time, right? If the in number is smaller, your value is negative. Negative how much? What word?
184.
184. So this is called this value in IG you must know it's called enthalpy change. So the enthalpy change is negative 184. So because it's negative, we know it is exothermic. Get it? Very easily. This chapter very easy, the calculation. All right. So, okay, what happens is we start off with hydrogen and chlorine. This is the reactant. Okay, this energy level profile. Okay, activation energy, EA, is the energy in or the energy out? Last week. Huh? Activation energy is in or out? In. Okay, so activation energy, because you cannot just form bonds, everything also must break bonds. Doesn't matter if you use more energy to break bonds or more energy to form bonds, it doesn't matter, you have to go in first. So activation energy is always energy in. So first you go in and you the EA. So the EA is how much? The EA is actually this one 678. So this is EA, activation energy. All right. So when we draw this, sometimes you always draw like that lah, circle. But you don't have to. Okay, so this energy in. The energy out is more or less than the energy in. More. That's why it's this is in minus out, right? So this is in. This in is 678. And then out is much bigger. It's 862. All right. So because it's bigger, this one don't draw first. From here to here is 862. All right. But the question only wants the label the reactants. Okay. The enthalpy change. So the product will be here. 2HCl, right? Okay. So do I need to draw this whole line? Actually, don't need. I only need to draw here and I label it. But this is where the negative, this is where the out comes from. Can you understand? This is the 862, the EA is this one. So in, out. So when the product is lower than the reactant, it's an exothermic reaction. Ah. So endo will be what? Endo will be like this lah. Endo will be in, but less out. Like that. And then when energy change will be positive lah. That's endo. So this is exothermic. Ah. Okay, kan? Okay, you know. Okay, don't worry, we will go through this again next time. Right? This paper done already, right? Okay, discuss. Okay, hold on. Uh, okay, this question, this chapter is called rate of reaction. So actually, the question on top here, okay, and the question below here are both from the same topic, rate of reaction. Okay, so what is rate of reaction? Rate of reaction is basically like this. Okay, so let's say you, got empty space. Okay. So basically, let's say you are running. Okay, phew, 100 meters. All right, you're running 100 meters. Now, how fast can you run 100 meters? Let's say you run 100 meters in 10 seconds. You're the fastest in Malaysia. Okay, strategy. So what happens is, what is your speed? You all learn physics, right? What is your speed? Distance over time. So you're 10 meter per second. So fast. All right. This is speed. Rate of reaction is how fast a reaction goes. So it's very simple reaction. So very few reactions that you need to know lah. So for example, this reaction here is marble chips and hydrochloric acid. So a few things you need to know lah. Okay, marble chips is a carbonate, calcium carbonate. So the two most common reactions that we study in rate of reactions are, even if you haven't learned it, you're supposed to know. Okay, because you learned them in year 7, 8. Have you learned this about year 7, 8? Acid and carbonate, salt, water, and carbon dioxide. You learned before? Eh, huh? Aiyo. Yola. Have you learned before? My heart is in pain. Because all the young kids, they will learn this. Okay, never mind. Okay, so the common reactions that we study for rate of reactions is we cut off the chemical run. Right or not? Okay, so the first reaction is, can you write this down? So acid and metal. Now you know that. Become salt and hydrogen. Okay, and then acid plus carbonate becomes salt, water, and carbon dioxide. And the third one is acid. Sorry, not acid. Hydrogen peroxide becomes water plus oxygen. Okay, let me write down the chemical equation for you. So, acid means any acid. So, for example, sulfuric acid, and metal like zinc. You get zinc sulfate and hydrogen. Okay. Acid and carbonate is any acid. So for example, let's say hydrochloric acid and calcium carbonate. This is the carbonate. You get calcium chloride, water, and carbon dioxide. And then hydrogen peroxide is H2O2. It breaks apart to form water and oxygen. Okay, can you tell me what these three reactions have in common? Okay, what do they have in common? Yeah, wait, I'm going to circle lah. If you don't know, I'm going to sit down and cry. They have what? They have what? Huh? This is what? Hydrogen is a gas, carbon dioxide is a gas, oxygen is a gas. A rate of reaction must be something you can measure. Okay? Must be something you can measure. So I said, I want to see how fast you breathe. How are you going to see how fast I breathe? I look at you, lor. Should be right. That's the next right? Okay? So it must be something I can measure, right? Or not? I want to measure how fast your hair grows. And look at you. It grows. Does that make sense? It's not. Okay? So it must be something I can measure. So I can measure gas that is released. Okay? Okay, gas that is released, we measure the volume. So the reaction, okay, no need to turn, just look here. The reaction on top here is, tada, we're measuring the volume. Okay, so this is called a gas. Oh, you need to write this down. It's called a gas range. Here we put the chemicals, hydrogen peroxide, and what happens is the oxygen gas will be released. Oxygen gas will be released. And then so what happens is on the gas range here, there are volumes. Right up. You know which paper? It's the same, it's that set, but the first the page five. Got it? All right. So what happens is rate of reaction, other than the volume of oxygen produced, what is another thing I must measure? Come on. What is another thing I must measure? For rate, how fast someone is doing something, how fast the person is running. I measured he ran 100 meters in seconds. So what is that? Time lah. So as soon as I start the experiment, I must press my stopwatch. And then I must look at my stopwatch. So either every 30 seconds, every 50 seconds, every 60 seconds, I must see what is the volume of gas collected. Get it? And so this person does this experiment. You must have something to release. So what is released is oxygen. So a student adds 100 centimeter cube of hydrogen peroxide solution to 20 centimeter cube of the apparatus and labeled A. Okay? The student records the volume of gas collected every minute for 16 minutes. Can you see that? Okay, so every single experiment, it will have exact same curve. Okay, every single experiment that you measure, that you do, you will have the exact same curve. First, very, very fast, and then after that, stop. Yeah, I'll explain to you why in a moment. But every single experiment, you will have this. Okay, now, uh, this one, what am I measuring? This one is the acid and carbonate. I produce carbon dioxide gas, right? So instead of measuring the volume, I measure the mass because here carbon dioxide gas, will it stay inside here or will it go out? Go out. So as the carbon dioxide goes out, this whole electronic balance will show it becoming heavier or lighter. Lighter. So the mass will decrease. So again, I measure the time taken for the mass to decrease. And I calculate, okay, why do we put a cotton wool? If we don't put a cotton wool, the acid will spray out. If we cover it, the carbon dioxide cannot go out. So we put a cotton wool to allow carbon dioxide. All right? Can you understand? Okay. So two things are two ways of measuring. You can measure mass loss, or you can measure volume of gas collected. Okay. Okay. Here are two things are. All right. So uh if I measure rates by measuring the volume of gas collected over time, or the mass loss over time. Okay, good. Yeah. Right. Mass loss over time. Or all right. Now let's talk about normal stuff. Okay. If I cook chicken, okay, I got two pots of chicken. One I use high heat, one I use low heat. Which one will be faster? High heat. Okay. If I got two chickens, one I put the whole chicken inside, one I cut into small pieces. Which one will be faster? Cut into small pieces. Okay. I have two chicken. One I use pressure cooker, one I use normal cooker. Which one will be faster? Pressure cooker. It's high pressure. Right. Okay. So those are the factors that affect rate of reaction. So I pour acid into the zinc. I pour concentrated acid and diluted acid. Which one will be faster? Concentrated. Okay. So the five factors that affect the rate. Okay. This one is in your syllabus now. It is, but not so detailed. Okay. Where do I put this? Okay. The five factors are here. Okay. Use little color pen. Okay. Temperature. So basically, high temperature, high rate, right? Okay. Concentration, pressure, basically high concentration, high rate. High pressure, high rate. Okay. Now, particle size. Which one will be faster? Small particle or big particle? Small. So I grind into powder faster. So it'll be smaller, it'll be fast, high rate. And the last one is, I'm sure you've heard it before, it's the same concept as enzymes. Enzymes are what? And catalyst. Okay, so basically, if I add a catalyst, I just have to add. It doesn't have to be high catalyst, low catalyst. No, I add a catalyst, it'll be high rate. Okay, okay. So these are the five factors. Correct. Okay, let's go. You know, okay, let's go back to our original. This graph. Okay, so you look at this graph. Like I said, just now all graphs will be like that, right? Okay, do you know what's a tangent? You learn in math, tangent. Okay, so this one, the tangent is very fast. You don't learn a tangent, you
I
know.
heard it.
Okay, this one is the highest tangent, this one less, and then this one zero. Okay, so that means the rate is always the fastest at the start, and then it becomes slower. Can't even spell. It becomes slower, and then it stops. Or the rate is zero at the end. It becomes zero. Okay. Why? Why? Huh? Okay, what was the answer? Why is the rate higher in any reaction? Why is the rate always highest at the start?
It has the highest amount of reactants.
I don't know. I have five factors B. Temperature, pressure, concentration, particle size, and catalyst. Which factor makes it the highest rate to find at the start? That means this one experiment, why is it so fast at the start? Is it the concentration, the temperature, the pressure, the catalyst? What can change in one reaction? I'm not comparing between experiments. It's just this one experiment. This one experiment. Why is it so fast at the start? Is it the temperature is higher at the start? No. The pressure is higher at the start? No. What is it that's changing? No, the catalyst is just there. Well, why is it fastest at the start? At the start of the experiment is always the fastest because the temperature, pressure, concentration, catalyst, and particle size. Which one is the highest at the start and then becomes slower and slower? Huh? There's no, this aqueous what? It's aqueous concentration. So in any reaction, okay, so rate is always the highest at the start because concentration is the highest. But concentration of what? You must always write a concentration of aqueous. So in this case, it's hydrogen peroxide. So of hydrogen peroxide. If another question is acid, then you must write acid. You cannot say the concentration of the calcium carbonate. You cannot say the concentration of the metal. It must be the concentration of the aqueous. Okay? So this question is hydrogen peroxide. So the concentration of. So then here, why is it slower? Concentration of aqueous, okay, decreases with time. And then here, the hydrogen peroxide is used up. When it's used up, it stops. Get it? That's why it becomes zero, is used up. Okay, write this down. Ah, now stop here.